Yes, here we are, and you can do it maths. And today we're doing the October-November 2021 paper 23. Here we go. Question 1, write 26 grams as a percentage of 208. It's like in an exam. You got 26, you got 26 out of 208. Hopefully that won't ever happen for real. 26 out of 208, and of course then you multiply it by 100 and you hammer that into your calculator and you'll get 12.5. Question 2, I can see many ways to do this question, many ways. All right, there are so many ways. You can do alternate angles, which means this angle is x. You can do corresponding angles, which means this angle is x. You can do co-interior angles, which means this angle x plus this angle here is 180. Of course, those are vertically opposite angles, so that angle would be 132. So co-interior is 180 minus 132, which is 48. Those are just 3 of the many ways to do this. Question 3, from the list, write down the number, one number, that is both the prime number. So let's look which ones are prime. Prime numbers has only got 2 factors, 1 and the number itself. So we got 11, 13, 17, and 19. They're all prime numbers because we can't divide them by anything else but 1 and the number itself. And a factor of 195. So here we need to go, we need to check, yeah. Can it divide into 195? Let's start. 11. Can 11 go into 195? Didn't think it would, right? It's 17.72. No. Can 13? Of course, you don't have to show all of this. Yep, 15. So the number there is 13 because 13 goes into 195. That's it. Done it. Question 4a, put a ring around each of the symbols that make the statement correct. Of course, 0.5 is 50%. That means that 0.5 is bigger than 5%. Okay, but of course as well, each of the symbols, details is important, all right? So there might be more than one, and there is, because 0.5 and 5% is not equal. So you need to circle that one as well, both of them. 4b, insert one pair of brackets to make the statement correct. At the moment, 7 minus 3 is 4, 4 minus 1 is 3, 3 plus 2 is 5. Okay, so what we want to do is we want to make one of those numbers positive. And if we put a bracket here, it will become 7 minus 3, multiply in that bracket, plus 1 plus 2, and that will be 7. 7 minus 3 is 4, plus 1 is 5, plus 2 is 7. Okay, a little bit of trial and error there, and you'll get it. Question 5, we have Nina, and she changes euros into dollars. So write it like a ratio. $1 is 0.9 euros. So she's got the euros. And we need to think of ourselves, how do we get from 0.9 to 153? What do we multiply it by? So we do the opposite. You do 153 divided by 0.9. That's 170. It means you multiply it by 170. And that's easy. So it's $170. Question 6. Marek buys a computer for $420. He sells it at a loss. So when you have a loss, percentage loss, it's always the same. You take the original amount, which is always 100%. You subtract 15% from that, and you end up with 85% of the original price, which as a decimal or a multiplier is 0.85. So all we need to do is do 420 times 0.85. Grab your calculator. 357. In the examiner's report, they specifically said these people who worked out 15% often forget to subtract it, and that costs them marks. This is the most successful method to do. Question 7, simplify. This is straightforward. 32 divided by 4, of course, is 8. And when we divide with indices with the same base number, we need to subtract the index. So 32 minus 4 is 28. You got it. Question 8, we got Beatrice. And hello, Beatrice. And we're talking here about speed and distance and time. So let's draw our triangle. Okay, remember speed is kilometers per hour, which means distance divided by time. Okay, now to work out speed, we need distance and time. What do we have? We have the total distance Beatrice has walked, that is 3 kilometers. So we got distance equals 3 kilometers. But do we have the time it took her to cover that 3 kilometers? No, we'll have to work that out. Okay, so let's see. First of all, we can do it. First part of the journey. Let's just make that first part of the journey. Okay, to work out the time, we need to take the distance divided by the speed. Okay, so she walked 1 kilometer divided by 4 kilometers per hour, and that will give us the answer, of course, in hours. So here we go. 1 divided by 4, okay, is 1/4 or 0.25, quarter of an hour. Okay, second part of the journey, she walked 2 kilometers at 4.5 kilometers per hour. So let's make that the second part of the journey. Her distance was 2 kilometers divided by 4.5 kilometers per hour. That leaves us hours. Let's work that out. Okay, so 0.4 recurring. I'm leaving it as fractions because I just feel that's more accurate at this stage. Okay, so what is the total time she's been walking? T will be 1/4 of an hour plus 4/9 of an hour. So we got the 4/9. We just need to add the quarter, and there we get. Okay, we can write the decimal value 694, but rounding at this stage is not a good idea because your answer isn't accurate enough. So what do we got? We have now, brilliant. We've got the distance she's walked, and we got the time it took her to walk it. So to work out speed now, we just need to take the distance divided by the time, 25 over 36. So on our calculator, 3 divided, put in our previous answer, equal, and we get a very accurate answer there of 4.32 kilometers per hour. Does it make sense? Yes, because it's between the 4.5 and the 4 kilometers per hour she walked. It's a reasonable answer. Question 9 is only 1 mark, so if you know the answer and you write it down, that's fine. But the method is to set this equal to x. Then because there's 2 numbers recurring, we multiply everything by 100. That will give you 100x over 2.7, 2.7 recurring. I'm writing that first part again. Then we subtract the first equation from the second one, so that will give us 99x. The recurring decimals will cancel. We got 27, and then divide the 99, so it's 27 over 99. Okay, do check with your calculator. Put in 27 divided by 99, and yeah, you see it got 2 little dots on top, and it's correct. Question 10. Read the question carefully, find the next term. Don't write the nth term here. So let's see, what is the difference? We subtract 4, we subtract 4, we subtract 4. So the next one would be negative 13, of course. Then the nth term rule, of course, is n minus 4. No, students still write this in exams all the time because it is not n minus 4. Okay, it is the negative 4 times table. Negative 4 times tables goes minus 4, minus 8, minus 12, minus 16. You see, we're subtracting 4 each time. Now we just need to find, yeah, so well, that's why it's minus 4n. first of all. First mark, you got it. The difference here from the sequence they gave us and the -4 times table is you need to add 7 every time to get to our sequence. So it's -4n plus 7. Or even easier, continue the sequence in the opposite way. Add 4 there, that is 7, because 7 minus 4, that's 7 is what we write at the end. And you have it. Question 11. First of all, there is a basic substitution question. M is 100, G is 3, and H is 4.5. Okay, let's make that plus loop here. Put it into your calculator exactly like it is. Don't waste any time. Don't try to be smart. Let your calculator do the thinking and you get the right answer. Easy marks. Okay. Then rearrange the formula to write G. See that they want G to make the subject get the G alone. Okay, so let's write this down. P equals M G squared plus H squared. Okay, always think, right, we want G to be the subject. So we're going to work backwards. What happens to G? If G was a number, if G was 2, what's the first thing that happens? It gets squared. After it gets squared, it gets added to H squared. And after it gets H squared, it gets multiplied with M. Okay, because that means multiply, right? We are doing that in the reverse order. So we start away with the last thing that happened to G. And the last thing happened to G, the multiply with M. That means we need to divide the M. Now we get rid of the brackets. So we go G squared plus H squared. All right. What was the second last thing? The second last thing was that adding. So we need to now move the H squared to the other side. It becomes minus. Okay. And it's separate there like this. And the first thing that happened to G, the last thing we do is get rid of that square. So that means we're going to square root it. Okay. Now it's very important that this looks right. Okay. That line above needs to clearly cover everything, including the H square. We cannot square root the H square. We cannot write P over M minus H. That's wrong. We can't square root when there is a negative or a positive. Okay, so this is wrong. The final answer is the one we had. That's correct. So square root of P over M minus H squared. Question 12. Just without using a calculator, it means you can't do this. Well, nobody is looking, but if you do this in the exam, using your calculator, you get the answer. 5 over 3. We need to write it as a mixed number, so we can change it by pressing Shift and that button 1 2/3. All right, that's the answer. But that is 0 marks in the exam because clearly used our calculator, we didn't show any working. So we need to show every step. First step would be 11 over 12 plus, and we need to get the denominators the same. In this case, by simply multiplying the second fraction by 3, we will get the denominators the same. So that's 11 over 12 plus 9 over 12. Next step, add them together. Remember, we only add the numerators, so that's 20 over 12. Then we simplify it. We can divide both by 4. So that will give us 5 over 3. And of course, then 5 over 3 equals 1 2/3. Now that we got all our working out, you get full marks. Full marks for getting the same denominator. Full marks for simplifying, getting the mixed improper fraction. And then you get the mark for the final correct answer. Well done. Question 13. Calculate. Let's do that. Let's calculate. 0.04 squared plus 0.03 times 0.28. Bam. Got the answer. Okay. 0.01. Okay, now next step, give it in standard form. So remember, standard form has got a number between 1 and 10, from 1 to 10 times 10 to the power of something. Okay, so here we're going to have to move the decimal points 2 spaces to the right to make this 1.0. And because we made the number bigger now, we need to put a -2 there. Okay, now if you're ever confused with any of this, you can change your calculator settings. For any standard form question, you press shift, you press setup, you press 3 for number format. We're now changing to scientific notation, and then you select 0 to 9 is how many significant figures you want. I go for 4 as a safe one, and now you see that 0.01 is supposed to be in standard form. There we go. Sorry, just had to put it there. For the 4 is 4 significant figures, but 1.0 times 10 to the power of -2. Okay. Of course, you want to put it back. You press shift, setup, number format. You want it in normal, and then you press 1 or 2, and now it is just again normal. Question 14, Venn diagrams. Here we go. Complete the statement. P union with Q. Remember, union means in the one or in the other one or in both. So everything, P and Q, right? So P and Q, P's got B, got C, then we got D in both, and then we got E, F, and G as well. Okay, just to help you out, if it was P intersect with Q, the other one, that set would only have been D, because then it has to be in the one in both. Okay, union means all of them. Right, find N. Students also care what that N means. N means the number of. How many is there? So how many, in this case, letters are there in Q? There is D, E, F, and G. So that is 4. And again, the number of P, not the complement of P, intersect with Q. So let's do this one a bit slower. It's a bit harder. So the complement of P would be everything outside of P. Okay. So that is A, E, F, and G, where it intersects with Q. Q, let's shade everything in Q. Okay, now intersection means it has to fulfill both those requirements. So this is where it overlaps. So only where I now have the blue and the yellow. Okay, we're talking about this one, where my requirements overlap. That is what we're looking at. And again, the answer is not E, F, G. The answer is 3. There are 3 elements there, E, F, and G. Okay. Again, just to help you out, for in case it was union, union would have been everything we've shaded. So it would have been everything except B and C. Okay, so for that one, the answer would have been A, D, E, F, and G. That would have been 5. Okay, they didn't ask that. Little bonus I'm giving you. Question 15 is reverse percentages, because we're moving backwards. So let's start. Right? The cost of a train journey increased by 6%. Now the calculation for that is always the same. If you increase something, you're taking 100% of the original amount, in this case the cost, and you're adding 6% of that to it, and you'll end up with 106%, which as a decimal or a multiplier is 1.06. Okay, that means we'll take the original cost of the train ticket and we multiply it by 1.06, which we increase it by 6%, and then we'll get the new cost, which in this case is $153.70. So because we're going back in time, reverse percentages, we now just need to divide this on the other side. So the original cost will be 153.70 divided by 1.06. Let's do that. 153.7 divided by 1.06, bam, 145. That sounds like a good answer. And it makes sense because the original price is less than the new price, and 6% is not a massive increase. Question 16, Joe and Mo. I love that, Joe and Mo. I'm going to get myself 2 puppy dogs and call them Joe and Mo. They share $26. Joe receives $5 more than Mo. So let's write that down. So Joe, Mo. Okay, let's see, Mo gets X, then Joe will get X plus 5. Okay, that makes sense. And then if we add that together, X plus 5 plus X equal to 26. So now we just need to solve that. X plus X is 2X. Subtract the 5. And then divide it by 2. Which gives us 10.5. X is 10.5. So that means Mo, who got X, gets 10.5. And Joe, who's the favorite, got 5 more, which is 15.5. Okay. Is that our final answer? No. They say write it in the simplest form. In the simplest form, the ratio means no decimals, because if we got decimals, the answer is infinite. So how do we change those to whole numbers? And here we can simply multiply both by 2. So if we multiply both by 2, it will become whole. So 15.5 times 2 is 31. 10.5 times 2 is 21. And that's our final answer. Question 17. Each interior angle of a regular polygon is 178.5. So let's just draw that. Let's draw a polygon, or part of a polygon, because we don't know how many sides it's got, so I can't draw all the sides. We just draw part of it. And the interior angle is 178.5. Okay, and they all are. That one too, and all the other ones. We don't know how many there is. Once we know the interior angle, though, we can work out the exterior angle. Just need to do 180 minus 178.5. I've got that, it's 1.5 degrees. It is great to know the exterior angle because every single polygon in existence, exterior angles always add up to 360. Always. So we just need to do 360 divided by 1.5, and we have the answer. 240 sides. Okay. This is a very, very multi-sided polygon. It will look like a circle. Question 18. The equation of a linear straight line, y equals mx plus c. So the first thing we need to find is the gradient. Okay, let me show you what's actually going on here. Okay, here we have the 2 points. And then, of course, if we connect them like that, we need to find the gradient of that line. And I think, as you can see, that is going to be quite a steep gradient. Remember, gradient is the rise, so how much we're going up. Cheetah is barking again. The gradient is the rise over the run. So as you can see here, we're going from -2 to 10, or we can count the squares. That is 12. And at the bottom, it's only 1. So clearly, that gradient is going to be 12 over 1. Okay. But without the diagram, how do you do it on your paper? Well, you can remember the formula for the gradient is the change in y. So it's y2 minus y1 over x2 over x1. The most common mistake students make is to swap that around. They write the y at the bottom and the x at the top. So let's label this correctly. Let's do this. x1 and x2 is the x grade, the inter coordinates, and y1 and y2 is the y coordinate. So we start with 10 minus -2, and at the bottom we got 3 minus 2. So that will give us 2 negatives, make it positive 12 over 1, which got a gradient of 12. So that gives us the equation y equals 12x plus c. So we already have the first part of what we need. Right, next is to work out the c value. And we've got lots of x's and y's to put in there. We've got 2 coordinates. I'm going to stick with the positive numbers. All right, so I'm going to substitute these 2 values in there. So the y is 10. and the x is 3. 12 times 3 is, of course, 36. Subtract the 36 and we get negative 26. So that's the C value, and that's what we put at the back. We've done it. Question 19, we're talking about a sector here, and we need to find the perimeter. Okay, very important. Perimeter, don't confuse it with area. We're not going to work out any areas. Right, so the perimeter of the shaded area, it's got two parts. It's got this arc here. So let's start with that, the arc. Okay, so remember, arc length, we need to use the circumference of the circle. Okay, remember, circumference is pi d or 2 pi r. Okay, not pi r squared, that's area. We're not doing area. Okay, since we've got the radius here, all right, we're going to use the second part. So it's 2 pi r. Of course, this is not a whole circle. It's only a fraction of a circle. And to find that fraction is, of course, the angle divided by 360. So the calculation we're going to do here is 2 pi. Radius is 12.6 times the angle we have is 80 out of 360. So let's hammer that into our calculator. 2 pi times 12.6 times 80 over 360. Bam, we got an answer. Right. You write all those decimals, but this is more accurate. 28 over 5 pi. Right, now, the shaded segment is got another part that forms the perimeter, and that is this chord, we call it, really. Chord, but just call it a straight line. Okay, this chord here. Okay, so how are we going to find the length of that chord? Well, it's part of a triangle. And when we got triangles, we think trigonometry. If it's a right angle triangle, we do Pythagoras or SOHCAHTOA. But this is not a right angle triangle. For all other triangles, we use the sine and the cosine rule. Okay, now what do we have here? We got a triangle, we got one of the sides, and we got the other side as well, because this is still the radius of the circle, so that's 12.6. Okay, if you ever get stuck with any circle, look for radiuses, they're always the same. Excuse me, I want to write that nicely. 12.6. So we got two sides and the angle in between. Okay, so that means we are going to use our cosine rule. There we go. Okay, cosine rule we always use when we are working with three sides and we want to find an angle, or we got two sides and the included angle. So B, C, and capital A. So that's what we're going for. We're going for cosine rules. Cosine rule is a squared equals b squared plus c squared. Easy, Pythagoras in it. And then we just add 2bc cos a. I like to use straight away the rearranged formula, square rooting all of that on the other side, so we don't waste any time. So let's just substitute our values in there. So we're going to do the square root. Now what is a, what is b, what is c? We want to make lowercase a the side that we want to know, which is this one, which makes the opposite angle capital A. Okay, meaning the other two sides is B and C, and this doesn't matter which order they're in, and here it matters even less since they are exactly the same. So it will be 12.6 squared plus 6 squared minus 2, 12.6 times 12.6 cos the angle 80 degrees. So let's put that into our calculator. Start off with square root, 12.6 squared plus 12.6 squared minus 2, 12.6, 12.6 cos 80 degrees equal, okay, massive number there, 16.198, etc. Don't round it yet. What is left to do now is add my two values together. So that will be 28 over 5 pi plus the 16.198. So I got this very accurate answer there. I can just add to it 28 over 5 pi, and I get the most accurate answer, 33.791, etc. Rounded to three significant figures, 33.8 centimeters. Question 20. A lot of students struggled with this one in the exam. Not many got it right. So let's do this slowly, right? We're doing a map scale. Map scale is always 1 to something like that. All right. And it's always first the value on the map and then the map value in real life. Okay. So the first problem we need to solve here is the units problem. To get the map scale, we need to have the units the same. So we're going to have to change one of these, and I'm going to go for the kilometer square. Now remember, if we change kilometers, so let's say if we were to change 3 kilometers to centimeters, we're going to have to multiply it by what? Okay, first from kilometers to meters, you times it by 1,000. Kilo is 1,000, and then 100, you times it by 100. Okay, which means we times it by 100,000. But be careful, we are not changing kilometers to centimeters. We're changing kilometers square to centimeters square, which means we need to also square that factor there. Sounds a bit insane, but that's how it works. Okay, so 3 times 100,000 squared, and yes, it's a big number. Okay, so big it doesn't fit on my calculator screen, and it gives to me in standard form. Luckily we know how that works. Okay, a 3 with 10 zeros. Okay, what's that? 30 billion. Okay, so now we got our ratio 18.75 centimeters squared to 3, make a nice 3 times 10 to the power of 10 centimeter squared. Okay, the next step would be to get that little 1 there. Okay, so to do that, we need to divide 18.75 by 18.75. That will give us 1 centimeter squared. Okay, so we do the same on this side. We divide the answer we have there by 18.75. Well, and that gives us 16 with 8 zeros. What is that? 160 million? No, 1,600,000. Okay, something big. Either way, so that's a 16 with 8 zeros, of course. Okay, and that's correct because that is the area scale factor. 1 centimeter square on my map will be 1,600,000,000 centimeter square in real life. Okay, so what do we need to do? We want a linear scale factor, which means we need to get centimeters to centimeters. Okay, how are we going to do that? Square root. Square root the 1, you get 1. Square root that, and we get the scale factor. So we square root, I insert my previous answer, so no danger of getting the zeros wrong, equal 40,000. And that's a map scale. Okay, so that means 1 centimeter on the map is 40,000 centimeters in real life, but also 1 millimeter on the map is 40,000 millimeters in real life. 1 meter on the map, got a big map, is 40,000 meters in real life. And we've got it. Question 21, with the help of our calculator, this question is relatively easy. Everything in the brackets is to the power of 3/5. So we do 243 to the power of 3/5. And we got y to the power of 10 to the power of 3/5. Remember, a power to a power means we multiply them together. Okay, so 243 to the power of the fraction 3 over 5, and we get the answer 27. 10 times 3/5 is of course 1.2. or 30 over 50, or 30 divided by 50, 30 divided by 5, sorry, is 6. Just don't break your head. Still your calculator. Okay, there you go, 6. And that's the answer. Question 22, simultaneous equations. Now you can see we got two x values, two y values, because we have that quadratic equation there. Okay, and just to make sure you understand what's going on, the first one is a quadratic equation, second one is a linear equation. They cross in two places. That's why we got two answers, two x and y's, two coordinates. Okay, now elimination method is going to be difficult here since we got that x squared. Substitution method is the best way to go here. Right, because all of this is equal to y and all of this is equal to y, it means they are equal to each other. Okay, and well, yeah, so we write it like this: x squared minus 3x minus 13 equals x minus 1, because they're both equal to y. So now to solve this, we just need to rearrange, set it equal to 0. So I hop this x over there. So we got minus 3x minus x. Hop the minus 1, which is minus 13 plus 1 equals 0. Simplify it. That gives us minus 4x and minus 12. Okay. Quadratic equation means we're going to have to factorize or use the quadratic formula. Examiner said students using the quadratic formula made a lot more mistakes. Okay, so it's easier to try and just factorize this. Okay, so remember what we're looking for here is two numbers that we multiply together to get minus 12. Okay, so that's what comes to mind is 3 and 4. That's 12. Okay, one of them have to be negative because it's negative. Now when we add them together, we need to get the middle term minus 4. So we can minus 3 plus 4 or 3 plus minus 4. Those are both not going to work because that's going to give us 1 and minus 1. So that was not the way to go. Let's think of another two numbers. 2 and 6 sounds like good options. Yes, that gives us 12. Okay, because I've got a negative 4 there, I would guess that minus 6 is probably going to be a minus, yeah, because 2 plus minus 6 will give us minus 4. See, now we got it. Okay, we got a positive 2 and a negative 6. Okay, double check your answer. 2 times minus 6 is minus 12. Minus 6 plus 2 is minus 4. We got it. Now we can solve this by setting each bracket equal to 0. Move the 2 across, we got one answer, x is minus 2. Move the 6 across, we got a positive 6. Great. So we got the two answers, minus 2 and 6. Now just to find the y value, we substitute that back into one of our equations at the top. The second one obviously will go a lot faster because that's easier. So let's do the first one here. So this, what was it? Y equal x minus 1. We substitute the minus 2 in there. So y is minus 3. And for a second one here, y equals 6 minus 1. Easy stuff. Y is 5. And we have full marks. Question 23. We need to work out AC. AC goes diagonally across from the one corner to the other. Okay. Now, as you can see, AC forms part of this triangle here, which has a 90-degree angle there. And if we use the triangle on the side, this triangle here, using Pythagoras, we can get this side here, and then using Pythagoras again, we can get AC. That's using Pythagoras twice, and it works perfectly fine. Okay, but there's a quicker way, right? If you can recognize that AC forms the diagonal of a cuboid. So if you have a cuboid and the diagonal going from the one corner to the far corner you can work it out quicker by doing Pythagoras in 3D. It comes down to, all right, AC will be the square root of the length square plus the width square plus the height square. So that is 12 square plus 5 square plus 4 square. Easy as that. 12 square plus 5 square plus 4 square. Okay. It just saves us time from having to use 5 and 4 to work out this one, and then using that one to work out that one. We do it all in one step. Now we get the answer 13.601, etc. Rounded is 13.6. Okay, and the mark scheme clearly tells you get 2 marks if you do that calculation and 1 mark there. Or if you split it up, you get 1 mark each. Question 23b wants us to work out the angle AC at the base. Okay, so having a look there, we still have AC with a base, means we need to find the angle between AC and AP. All right, or to make things more clear, okay, if this is AC, then we have AP at the base here, and we want to know this angle over here. Okay, we'll call it angle CAP. In that triangle, we have the height 4, and we have the length of AC, which we just worked out, which was 13.6. When we work with a right angle triangle, we can either use Pythagoras, which we just did, or if there's angles involved, we use SOHCAHTOA. So for SOHCAHTOA, let's label the sides of our triangles. Okay, opposite the 90-degree angle, we got the hypotenuse, and opposite the angle we want to know, we got the opposite. So let's start writing things down. We want to know angle CAP. We're using the hypotenuse and the opposite. So for that, we use the sin ratio. In the sin ratio, we write the opposite first, 4 over 13.6. To get angle CAP, rearrange that. Use the inverse, sin to the power of minus 1 on the opposite side. Okay, on our calculator, shift sin fraction 4 over 13.6, close the bracket, and we get the answer 17.104, etc. Rounded to 3 significant figures, 17.1. And once again, we've done it. Question 24, trigonometric graphs. Let's start solving this equation, tan x, like we would solve any equation, and that's isolating the x. So we move the tan to the other side. That gives us tan to the power of minus 1 square root 3. Let's put that into a calculator. Shift tan square root 3, close bracket, equals. Beautiful answer we get there. X equals 60 degrees. That is one of our answers. Okay, but we need to remember what the tan graph looks like. Make yourself a little sketch if you forget. Okay, it looks, of course, like this. Right, so the answer we got was 60 degrees. So that would have been something over here. Okay, so over there, 60 degrees. And if we go to the side there, we'll get square root 3. Of course, square root 3 being 1.7 something, yeah? Square root 3 over there. Now, if we continue with this graph, let's make a nice straight line there from square root 3 across. You'll see that we cross the tan graph again within this 360 degrees over there. Okay. So we have another answer coming down here. See that? Okay. So what are we going for here? Remember, everything is symmetrical. So these two parts of my tan graph is the same. This part here and that part there. You see that? Meaning the distance here from 0 to 60 will be the same distance here from 180 to, you've guessed it, 240. Okay, or 90 minus 30, 240 minus 30. So that would be our other answer we are looking for there. So when we calculate ton, we need to do 60 plus 180, which gives us 240. So the answer is 60 and 240 degrees. Okay, examiner's comments with these questions is always students that have drawn themselves a little drawing of a ton graph is usually the ones that gets it right. Okay, you can do it. Question 25. Let's have some fun with algebra. First thing we're going to have to do here is factorize. So looking at the numerator there at the top, common factor of 3 and 18, of course, is 3. And there's also a common factor of an x, so we can factorize out 3x. Now 3x times x will give us 3x squared, and 3x times minus 6 will give us minus 18x. Always multiply them out again, the opposite way, to check if it's right. Now that is great because we know 99% chance it's going to be an x minus 6 below the line. Our next step would be to break the bottom one into two parts, right? We're going to factorize those first two separately and those two there. So let's have a look. Okay, the first two terms there, we got a common factor of a, and things are looking good because a times x is ax and a times minus 6 is minus 6a. Okay, next part there, common factor of 2. We've got a common factor of 2, yes. And a c. And again, 2c times x gives me 2cx. And 2c times minus 6 gives me minus 12c. Now, the biggest mistake, most common mistake being made now is cancelling like that. That's wrong. Can't do it. Okay, that plus there still means you can't just cancel it, right? That step is wrong. Okay, what we need to do before we can cancel, we need to factorize some more. So the top part stays the same. And here at the bottom, we can factorize out the x minus 6, x minus 6. Put that in front. Okay, so x minus 6. And what is left then is an a plus 2c. Now we can cancel the x minus 6, and we're left with 3x at the top and a plus 2c at the bottom. And you got it. Question 26, vectors again. Just look at it very carefully. Right. Read all the information. ORT is a triangle. We can see that x is a point on TR, so TX to XR is 3 to 2. Let's write that down. So the ratio here is 3 to 2. What that means is we have divided that line into 5 parts. 3 of those parts, or 3/5, is TX and 2/5 is XR. Okay, it's important to see it that way. O is the origin, that's where everything starts. Okay, the rest we can see. Find the position vector of x. So what we're looking for here is this. Positions means we start at the O, we go to x. There are two paths we can follow. The one I'm going to pick is this one. Okay, from O to R, and then from R to X. We know what O to R is, that is R, but we don't know what R to X is. Okay, so before we can work that out, we need to find that one. So first, I want to know what is RT. So we want to figure out what is RT in that direction. RT. Follow a path that we know, going from R to O and from O to T. So RT is RO plus OT. which is RO. We're going in the opposite direction of that R, which would be negative R plus OT is T. So minus R plus T, if you want to make it look nice, T minus R. Okay, that way, now we got RT. Brilliant. Okay, we can write it in there. Let's write it in. So Rx would be 2/5 of that T minus R, and XT will be 3/5 of T minus R. Things are looking good. Now, let's go back. Remember, we were going from O to R and from R to X to get OX. Or if we write it down here, we want to know the vector OX, which is the position vector OX, and that we're going to get that by doing OR plus RX. OR being R and RX being 2/5 of T minus R. Let's simplify that, multiply out the brackets. That gives me 2/5 T minus 2/5 R. So R will be, imagine there's a 1. 1 minus 2/5 is, of course, 3/5 R, and the 2/5 T stays the way it is. And that's the answer. Let's just write it on the line. 3/5 R equals 2, not equal, plus. Okay. You've done it. Well done. Well done for making it to the end. Hope you enjoyed. Hope you found it helpful. I enjoyed this paper a lot. Please leave comments. Please subscribe and like. See you again soon.